equilibrium, you know that some of the ester and some water have been formed. So therefore, at equilibrium, the amount of acid that remains is equal to 0.0435 minus X, because that's the X moles of ester and water that have been formed. Same for the alcohol. The amount of equilibrium is equal to 0.0435. Take away X, because that's the moles of ester and water that have been formed. So we've formed X moles of ester, and because it's a 1:1 ratio, we must also have formed X moles of water. So if we now construct the expression for Kc, that's equal to the concentration of ester times the concentration of water divided by the concentration of the reactant, which is the concentration of the acid, multiplied by the concentration of the alcohol. In this case, because there's equal moles on both sides, volume cancels out, so we don't need to convert moles to concentration. So if we now simply put in the values that we've been given, Kc we have been told is 4.07. The concentration of the ester and the water are the same, which is X squared. The concentration of the acid at equilibrium is 0.0435 minus X. And since that's the same as the concentration of alcohol, we can also square that. All that you now need to do is to rearrange the equation to get X. Once you have X, you can therefore work out the amount of acid, because you know the total amount of acid is the acid catalyst that you added, which hasn't changed. And you were told that was 5.00 times 10 to the minus 4 of catalyst at the start, plus X, which is the amount of ethanoic acid. So that will give you the moles of acid. Now you know the moles of acid, or the moles of H+. We know that the moles of H+ equals the moles of hydroxide ions. And if you use the equation, number of moles equals C times V over 1,000. Rearrange this equation to get the volume. So the volume equals number of moles divided by the concentration times by 1,000. And there